1. Oh, that's better. So far we created only the beginning of the stream. We have the top of our library. We have created publisher. But in real library, we have much more things, right? We have like operators, which allows us to transport A to B, to filter something, to flat map another street, and all of this kind of cool operators, right? That's why we love reactive programming and reactive streams, because of this, because of all these kind of operators. So now we are going to create a few of them. We won't have enough time to create all of them, because the last one is super complex. The first one is pretty simple, but we will start from the simplest in order to understand how the operators are structured. So you will be able to understand what you are doing when you're creating an operator, how many objects are you creating, how they work under the hood. And by doing that, we will be able to create our own library at any point in time, because this is basically all we have to do to know about composing and kind of operator composition. So in order to start our journey to operators world, we have to understand the life cycle of reactive streams. This is an important point. So let's take a look at plain execution flow. Just imagine that we created our first step as array publisher, but now we want to create a map, another map or filter, it doesn't matter. But the most important part, when we start chaining our kind of operators, when we created a source, then we added map, then we added map, then we added filter, we don't do any data processing so far, right? We just assemble a pipeline. We create this pipe and then chain another pipe, which do another thing, we chain another pipe, we chain another pipe. Because in order to start something, we have to subscribe. Do you remember that? That nothing happened until we subscribe to our stream. So someone at the very end of pipeline have to just open the top and start kind of the runtime. So this is assembly. Assembly time when we gather everything in one chain. What happens afterward? Once we got a subscriber, we called a subscribe method. This is basically creates a subscriber to our environment. This subscriber literally flows up to the publisher, because we have a chain of subscribe method. So after some point in time, our publisher will get a subscriber and will call on subscribe method. This is due specification. This is clear, right? So once it called on subscribe method, it will send subscription to our subscriber. But at this point in time, we made a first handshake. And this handshake called subscription time. So first we gathered or assembled our pipeline. We got a subscriber, we got a handshake, which is called subscription, because this is just an exchange of subscriber versus subscription. And finally, once we do all this dancing with subscriber, subscription, and our pipes, we can request for some data, for example, for the same 5 elements. This request will go to our publisher, to our subscription, and then subscription will be able to start sending elements through the whole pipeline, or call on complete method. And this time, when all this element will be going through the whole pipe that we created, that we assembled at the very beginning, we'll got a name runtime. Yeah? Does it make sense? So to summarize, we have assembly, which basically means that we create publishers. Then we have subscription time, or yeah, subscription, which basically means that we exchange subscriber versus subscription. So it's 2 calls to relates to this phase. And finally, we got runtime, which is invocation of request methods, on next method, on complete method, and on error methods. Does it make sense? Okay, so now we know the life cycle and the phases of every reactive stream library. Now let's take a look at the same code. So where we have to put, yeah, I got an answer. Now we want to create the data processing. We want to put these lambdas to our chain, and we have to somehow apply our business logic. Where we have to put this business logic? I gave you an answer. Yes, we need an element to which we have to apply our lambda. So we have to put our business logic somewhere inside subscriber. So it basically will be like that. We got a subscriber, So this element will go through all the changes, through all the chains, and under the hood it will look like that. So we'll got subscriber, which is calling another subscriber, which is calling another subscriber. So it's basically will be like that. For example, if we want to create map operation, we will create map subscriber. We will got map subscriber through the whole chain up. So our array publisher will be sending element to one map subscriber. Map subscriber will do some mapping, send another element to another map subscriber, and afterwards we will get our element at the very end, at the very bottom of our execution stream, at the subscriber that we provided by ourselves. So this pattern is basically plain decoration, or I call it a Matryoshka pattern or Russian doll pattern, because basically the whole execution flow looks like that, and here is we are there, like at the very middle of execution. The rest of the kind of chains or the kind of decorations are other publisher that just put business logic into our execution, but the main recipient is the middle. Does it make sense? Great. So here's actual subscriber here. Let's try to implement the first subscriber, the simplest subscriber, our map subscriber. Let me quickly switch to the next step in our execution. And now I have to figure out where I am. Yeah, here I go. I added some additional package, some real application to which we can apply all of these operators afterwards. So this is imperative. We will transform this imperative to reactive afterwards, but just for your information. Now we are going to try to create another operator. So as it's clear, everything should be hidden inside subscriber. So let's create map subscriber. Yeah, let's add it to the Git. And now we have to implement by our subscriber the subscriber interface. Subscriber interface. So we have to implement those 4 methods. And now we have to figure out what to do next. So first of all, we have to get a mapper, or function which map A to B. So it's clear we have to put it somewhere. Final function A to B. So we have to define a generics here. So we have to define a generic in and out, which means input and output. And now the question, what should be there? So since this guy should receive elements, it means that our type should be input, right? So we have to map input to out. So we receive input, so we map this input to output. So this is input value, and we have to produce output value. So this should be function into out, and we have to call it mapper. So we have to add it to constructor. And now it's clear that we basically have to call this mapper, apply our input value, and produce output value or result value. Here we go. Now the following question: to whom we have to send our output value? So we have to, like, in order to make this chain, like on the image, we have to have a next subscriber in the chain, right? We have to have a delegate or actual subscriber. So we have to put in the same final field subscriber, which is basically accept all kind of output, right? And we call this guy actual subscriber. Here we go. We got function which maps A to B, and we got a subscriber which received B afterwards. So now the question is that we have to send to do proper chaining or delegation. So we now have to just send this result value. And now, along with all invocation, we probably have to do proper delegation. So we have to call the same onSubscribe method here with subscription. So we have to call the same onError with throwable, and we have to call the same onComplete. So we are literally delegate every call. Yep, does it make sense? All right, since we are done, looks pretty straightforward, so we can do whatever we want with this chaining. But now let's go to the slides. And let's try to think about real business logic. Just imagine that we want to implement or transform this code that we basically saw, that I have shown in our application. So this is a part of our processing flow where we map A to B. So this is basically like we got an object, like order request, we apply some action and transform it, order request to some currency grouped order. So we do some business logic here, then here on mapped object, and here on mapped object, and here on mapped object. So it's a flow of mapping one into another. Yep. Now imagine that we want to do that in the proper way, in the reactive way, because everything should be and could be asynchronous. We can be, this method could be just a controller method, so we can receive a stream of objects from the network, and we want to write everything asynchronously to the network back. Now the question. We have a map publisher. Yeah, so it's clear that it's publisher API. That's how we write our API today. Do you do the same? Like flux and return flux, or mono and return mono. Now we have to do mapping. So instead of doing kind of imperative mapping, we have to compose what we created, like map subscriber, with the function. So it's clear that it's really simple to transform our method to function invocation. This is a feature of Java 8. But now the question, where we have an access to subscriber. Like we have to pass like in our cases, this is a second element, but it's clear that we have to pass a subscriber to whom we have to send methods, right? Then of course we can apply the same transformation to every stage, yeah? Like we just replace it all the operation with subscribers because we have map subscriber. But now the question how we have to chain all of them. So one of the options, like obvious option, we start looking from up to down. So we will try to put grouped order to kind of exchanged order and exchange order to order total and so forth and so on. So we will try to pass upper objects to lower objects. Yeah? Does it make sense? Yeah? No, it doesn't. Because in fact, in fact, we have to do other way around. Because basically this function maps this element, like this element, to another. And the recipient of this mapping should be this guy. Not other way around, but from down to up. So our chaining should look like this. So our objects should be chained in an absolutely different way, right? And this is fine. But again, now the question, we still have a gap here. We still have a subscriber which has no recipient. And the recipient of this subscriber is subscriber somewhere out of our methods. Now the question, how to get an access to this subscriber? Any idea? I can show you. Like, let me show how we can do that quickly. So what we have to do afterwards, like just imagine that we got this asynchronous API, and we mapped this asynchronous, this asynchronous API to publisher one. So we got a publisher here, and we got a publisher there, and we got a publisher everywhere. It's like a song. So this is basically our code. Now we have to somehow return the publisher because this is an API requirement. So one of the options is to do something like this. Publisher, and here, as you can see, if we return a publisher or try to implement it as an anonymous class, this will be a subscriber which comes out of our execution, which should lead to another sort that we have to apply another decoration to everything, right? Not only to subscriber, but to publisher as well. And in this way, we will have an access to a subscriber which from downstream. So now, if we're going back to our code base, yeah, we have to remove this guy as well. Yep, let's do that. We have to apply not only decoration to runtime, but to assembly time and maybe to subscription time. Let's take a look. So basically what we have to do in order to make everything chainable, we have to apply the same, like more clear decoration, because this is decoration from up to down, because, yeah, the previous one was tricky because we are doing logical operations. So this is the first mapping, this is the second mapping, this is the final mapping. But we are doing everything in a different way because at runtime, we got a subscriber from very down of the stream to very up. That's why we have to rewrite everything in the reversal way. But with this way, with this kind of composition, this publisher composition, we can preserve the logical mapping from up to down. And it will look like this. So once we subscribe to this chained decorated pipeline, we will get our subscriber, which will be wrapped into another subscriber, which will be wrapped to another subscriber. So our top publisher will be able to call unsubscribe on the toppest kind of doll, Russian doll, and send the same or delegate the same call through all of them. Yeah? Does it make sense? So let me implement this. So now we have to, what we have to do, first of all, since the map subscriber should be probably internal part of any publisher, because publisher only should have an access to subscriber and should provide proper delegation, so we don't have to leak access to that. We have to create map publisher, which implements publisher, and it will be the same. So in this case, it will be output, because yeah, in previous case, the subscriber is an input itself, but publisher is an output. So in previous case, publisher was input type, but in this case, since we are doing map publisher, which does A to B, and the output of our mapping should be B. That's why publisher, since it's a producer, should be of type out. And we have the same in, the same out. Now we implement our subscriber. So here we get a subscriber, as it was in our map subscriber. Do you see that? Subscriber, which extends out, and we get exactly the same here. So this is basically our actual. Now we have to, in order to make proper chaining, we have to introduce final publisher of input type, which is parent. So we created a parent. So we have to create the same final function in, come on, and out, which is mapper. So we got the function, we got the parent, and we got the mapper. And now we have to move our map subscriber to here. So yeah, let's make it private, or at least package private. And now what we have to do in order to preserve chaining, we have to take our parent, we have to call the subscriber on our parent, but now we have to supply a different, not the actual one, because if we just supply an actual, it won't make any sense. It won't provide any business logic. But we have to wrap our actual subscriber, so we have to provide, yeah, actual subscriber into map subscriber. And in this way, we will do proper delegation of all the execution flow. Do you see that? Does it make sense? Yeah? Is it clear so far? So good? Okay. And, huh? One. Why two? Say it again. Yes. So the subscriber is a part of this interface. So we just do a proper delegation, like we got the call to subscriber, so since we are just decorator, we have to delegate, in general, the subscriber call to upper one. So that's why we call to parent publisher, but we have to do some business logic or provide some additional business logic, so we have to create some wrapper now around the subscriber for runtime. Yeah? Is it clear? So, in this way, we will be able to provide a proper implementation of our map publisher, so we can just modify a little bit our TCK in order to make sure that everything is absolutely correct. So let's try to do some long to stream mapping. So let's just do our publisher verification to expect string. And now, or just long, whatever, and just do function, we'll put function identity in order to make sure that everything or not. Let's do that stream one, so it doesn't matter. We are going to comment everything afterwards. So now we have to kind of compose everything. So now we have to create map publisher, as we do that, as we usually do. We have to wrap a parent publisher, which is array publisher, right? And we have to provide a mapping function. So we receive element, long element, and we have to map this long element to string. That's what we are doing here. And we can do, for example, yeah, let's keep it long. So we create another map publisher which maps string to long afterwards. So it will be a funny chain of mapping of doing nothing. But yeah, let's take a look at that. So here we provide another publisher that invokes long, parse long string here, and parse long string back to long. So it's funny chain, but it's clear what kind of structure we got afterwards. Do you see that? Do you see this pyramid? Should I just turn my laptop in a different way to see this pyramid? Yeah, this is somewhat not good, but let's just start from something, and let's run the TCK and all of our verification in order to make sure that it works. Yeah, it seems this is correct implementation, right? All tests are passing. Amazing. So let's go back to our slides, and let's try to summarize. So we have to change everything because our subscription will call on next, etc., and so forth and so on. Basically, under the hood, it looks like this. So we have a chain of subscribers which execute another subscriber inside and then another subscriber inside and so forth and so on. In turns, we have the same chain of publishers which at the very subscription stage, or subscription stage, invokes subscription at parent subscriber, at parent subscriber, at parent subscriber, which leads to subscription on subscribe and the whole delegation. Yeah, does it make sense? But let's consider some corner cases. Since user is not related and user code is not related to any Reactive Streams specification, and probably any user won't care about any specification, right? What we are doing, we just provide a mapping function, filtering function, and whatever. But just imagine the case that for some reason, our mapper function returned null, just a bug or whatever. What do we know about nullability so far in Reactive Streams specification? Right. So it's in general it's prohibited value, and in case we got on null from our mapper, we have to throw an exception in a proper way, right? There could be lots of other different cases because our mapper should end up with throw an exception because something went wrong and we got an exception during mapping. For example, we decided to divide 0 on something, or it happened that we divided something on 0, so it leads to arithmetic exception. We can't prevent that it's user bugs. But our reactive streams should just work and should provide a notification about error in a proper way, right? So what we have to do? First of all, let's go back to our implementation, and let's provide a test which makes sure that our implementation is broken. So here I have a test which basically creates array publisher, which maps A to B, like long to string again. But for some reason, I create here runtime exception. I can return null. It should be fine as well, but my test expects that someone will be thrown. So once something is thrown, I expect that on error will be called, and no on next will be received, and I receive only one on error call, right? All should be correct due to TCK. So now I'm running this test, and what will we see? What we will see? We will see that something went wrong. First of all, something went wrong because what we got, let me double check it. We got a runtime exception here. And this is somewhat unexpected. We had to receive an exception in a proper way, not thrown, but received in a proper way. It means that if I'm going to run this guy in debug mode, I won't ever reach this point. in my debugging. So I got the first breakpoint here, which is subscription time. Oh, nope. Nope, like that. No. Yeah, not this. Okay, so let's just F9. But yeah, I just got an exception thrown because there is no logic which handles all of those exceptions, right? So it's clear that I have to somehow, yeah, if I'm going back to my map publisher, I need to somehow wrap this mapping to try catch, right? To try catch, I have to catch all throwables ever possible to catch. And now this guy should be probably here, and the result value should be like this. And now I have to call an error with my throwable and return, right? But is it enough to fulfill all the requirement? Let me just try to run that. Yeah, we reached the first invocation, so the exception were delivered in the proper way. So the exception, runtime exception for test got caught. But yeah, again, I'm checking, and I got another runtime exception because nobody said to upstream, please stop sending data, right? So we have to cancel or something like that. All right, so let's go quickly to our slides, and let's do a quick summary. In case of nullability case or an exception, what we have to do, we have to say cancel to upstream in order to identify that the issue happened. Since we are a middle stream, we have to, there is no other way to notify about kind of please stop send data except the call the cancel on subscription. And we have to send on error to downstream. In general, yeah, we have to remember null is unacceptable, must throw NPE, cancel upstream, on error downstream, and yeah, must not process any more elements. This is important cases for data processing. So let's go to final implementation. And now since we have to, cancel, come on, the subscription, we have to have an access to this subscription, right? So far we don't. We just got it here, and we just send it downstream. So now we have to store it somewhere, right? So it's basically in order to get subscription, to get an access to subscription, we have to store it somewhere and call it upstream because it's basically an upstream subscription. Now we have to put this subscription here, put subscription here, and now the question, should we delegate the same subscription downstream or should we create another one? Just imagine that we just canceled and someone requests afterwards, but this is due to specification unacceptable. Or we send a terminal operation, but someone decided to, since it has a control on subscription, decided to request for a few more. So we have to protect ourselves. So we basically don't have to send the same subscription because it could be simultaneous invocation on the same instance. It could cause lots of, and create lots of problems. One of the patterns is, of course, delegation. So we can do something like this. But again, we cares about performance. We have to create less object. We have to produce less trash. So why not to just implement everything in one class? Is it possible? It is. We did like this. So we are sending ourselves to downstream. And what we have to do, we have to just provide a proper chaining of everything. So we have to say upstream request. And that's it. We have to say upstream cancel. And that's it. And this is properly fine. Now we have a control on all subscriptions that we got from upstream. Now we can safely call cancel because we knew that nobody had an access to upstream subscription except us, so we can safely call cancel and then say on error. We have to provide a few more kind of resistance to our stream because, again, you have to remember cancel is a synchronous action potentially. So the publisher will get aware eventually about the cancellation, it will eventually stop sending. So we have to protect ourselves about subsequent on next after an error. So we cancel it, but there is no guarantee that cancellation will happen immediately, so we still have to expect that a few objects can come here, but we don't have to send them to downstream because we have already on-errored. So we have to create an additional field like boolean done or terminated. And we have to say, once we call it on error, it doesn't matter was it from upstream, was it from downstream, we have to say that we terminate it. If we terminate it, all subsequent invocation of an error should be just end up with nothing. So we have to put this field here, and of course we have to put this protection here. And this will give us full guarantee that even so we asynchronously cancel the subscription of upstream, we will be protected that no more elements will be delivered to downstream. Yeah? Does it make sense? Now if we're going to rerun this test, we will see that the on error will be called once, and the test will be passed. Amazing. So now we got everything in our arsenal. And all the patterns you have to remember, because you will see them in the real libraries, is that intermediate operators like subscriber, filter, like map, filter, take, whatever you want, extends at the same time subscriber and subscription. So let me go to map, flux map. Flux map, here is flux map. Here is all the object it has, so I have to go to map subscriber. Map subscriber in turn kind of implements inner operator. Inner operator is in fact inner consumer and producer, another few wrappers just because of Reactor infrastructure, but inner producer is a subscription. Inner consumer is a subscriber. Like it's core subscriber, but in fact it's subscriber interface. So as you can see, all libraries like RxJava, like Reactor implements both of them in order to save the memory, like in order to decrease the number of created objects. And usually intermediate operators implement inner operator, which is basically subscriber and subscription at the same time. And now you can see the same business logic. Like there is a few more verifications, but in general it's fine. Like the same delegation, the same verification in the next. Reactor is a little bit more smarter. Just imagine that you canceled the stream from WebSocket, but your WebSocket is WebSocket from Netty. Netty produces byte buffs. In case you start dropping byte buffs, there is a high chance that byte buffs won't be released. So you have to provide some business logic which allows you to handle dropped elements. So basically, we can create the same logic of handling some cleanup of receive it afterwards object like byte buffers and provide some additional cleanups after cancellation. But in general, the rest of the things, yeah, we have to protect about nullability for ourselves. So we have to put the same kind of logic here. We have to use require not null in order to protect from nullability. But the same was in flux map. Good for me to notice that. Then we have the same business logic mapping like we call on error. There is a few more logic in Reactor, but it doesn't matter. And yeah, on next error is basically under the hood cancels the upstream subscription here. Yeah, just skip this more business logic because there is in Reactor. Reactor is much more complex. But in general, there is cancellation of upstream subscription. This subscription is basically taken from our field. And then we are sending on error, which is basically set down to true, propagate error to downstream, and in case we got something in addition, it just drop everything. Yeah? Does it make sense? This is basically how it works. All right. We don't need, because the same guarantees. We have a guarantee from Reactive Streams Specification, which says that all fields will be invoked serialized. Let me show you. So if you're going to look at the yeah, I have to, yeah, it's master, that's good. Serialized. So, serial. Yeah, serial. Yeah, this is a rule 1.3, which says that publisher must signal all methods in a serial way. Do you see that? Serial. Yeah, this word. If you're going to look at the serial notion here, can you read? Yeah, you can, I guess. We can see that serial means non-overlapping, which means non-concurrent or non-simultaneous. And it says that proper like atomics, monitors, or whatever should happen, which means that there is happens before from Java memory model, which means that all synchronization will be in place, and we don't provide as in the same case as with like integer index, which is non-volatile. We can apply the same to all fields in middle operators, which doesn't assume to be invoked by several threads. Since we know that done will be invoked either on next or on error or on complete, and only here we don't have an access to this field from, for example, from request and from cancellation. There is a guarantee, like from specification, that all this method will be invoked serially or one by one with proper locks and synchronization, which means that we don't have to care about concurrency here and everything on next, on error, on complete. So it could be just a Boolean field without any additional volatiles. All right. So we almost out of time. We have to summarize everything, and we have to change the same subscription as along with subscriber and along with publisher. And yeah, basically we can create take operator, filter operator, but you will see the same code, so it won't be interesting for us. To summarize, everything should be decorated, subscriber plus subscription to save the memory, and in general, yeah, straightforward code, decoration save the world, and now we have to fight this code, this pyramid of doom, because as we have seen before in our array publisher test, we got a pretty ugly code like this. And in case we want to create some beautiful data transformation, data mapping in a synchronous way, we don't want to write the code like this, right? Your user don't want to work with such API. They want to work with such beautiful API like map, like functional API where you can call map, filter, etc., and so forth and so on. So now the question how we can achieve that API. Do you know any patterns that allows us to get this code? The code like in Reactor or XJava? Have you ever heard about builder pattern or immutable builder pattern? Yeah? So the immutable builder is basically about if you call some method, you have to take some current state, wrap it into another builder, and return another builder. If you do any action, you have to wrap anything to something new and return it. In this case, we got some method like map, which could be intermediate builder step, which should wrap, like in the previous cases, current publisher, which is a current builder, to another builder, and that's it. And in case we want to create a builder, we have to call a static method like from array, which returns the initial builder state. Yeah, that's easy. So let's do that. Let's go for immutable builder. This is almost the same. In order to create immutable builder, of course, one of the options, like we have a common state, right? Common interface. But now, in order to provide all these builder methods, we would have to write map on every in map publisher. We have to copy paste the same map actions to our map. We have to provide the same kind of list of methods for every publisher, for every implementation, so they will be able to chain it with the same API. Instead of copy-pasting all these methods, we can create an abstract class which just has an access which will be extended by others publisher. But yeah, let me just simply show what I'm trying to explain. It will be much simpler. So what we have to do, we have to create something like flow. The flow will be abstract guy which implements the same publisher of T, so it will be absolutely generic like a publisher, but this guy will have something like public flow kind of k, let's name it, with map. So it will accept function t, why t? Because we are t, we are the current state, to k, so it's basically mapper. And what it does, it will just do something like mapper publisher. It will take this, because we are publisher as well. We don't know which particular publisher, it could be any publisher, but we know that we have to pass this, since this is a parent. Apply mapper and return new one. Now what we have to do, instead of kind of following all this publisher by publisher interface, we have to say, okay, now this guy have to extend flow, because flow is kind of generic publisher which has all of this API, which we want to extend for every publisher in our ecosystem. And now, as you can see, it will be the flow, but it will be with mapper. In fact, it will be mapper publisher, but it extends the same API, so we will be able to apply afterwards on the new publisher another one mapping. Now what we have to add, we have to create kind of new builder. In this case, it will be public static something t, for example, again, from array. You want to pass, for example, t generic array like elements in order to make this API more, we have to say flow t, because we don't want to specify which particular type we want to return. So we specify, what does it say? Identifier of type expected. What does it, come on. Yeah, now it's better. And we want to return new array publisher from elements, and with type t. That's what we want to create. But now we have, in order to make array publisher get all this API, we have to say, okay, buddy, please extend the same flow, and now array publisher will get all this API as well. And here we go. This is all Project Reactor under the hood. So now we know how to create array publisher, the source, and you will see the same API everywhere. If you're going to look, if you try to create publish, kind of observe on or publish on operator, which allows you to switch from one thread to another thread, everything will be built around the queue. And the queue is almost the same array. Like, what would we have to just drain elements from the queue and send to downstream? For those who curious, I can continue my explanation. For those who will tired, you will be able, let me just summarize, and for those who curious, I will show what could happen afterwards. But in general, right now we have the almost the full API, and instead of writing, let me go back to my map test, not Flux array test, array publisher test. Now instead of writing all this pyramid of doom, I can do something like flow from array, generate elements, then map my element to string, and then map my element string back to long parse long. And it will be absolutely the same code, absolutely the same chaining, hidden by beautiful API. So now if I'm going to rerun all this test, you will see that everything will just work and work as expected. Yeah? Cool. So, is it simple? Now you know everything about all reactive libraries like RxJava, Project Reactor. Akka Streams is a little bit different, but the patterns are pretty the same. Now let's do final summary. The main idea is immutable builder and nothing else. Now let's talk a little bit about optimization, because this is important. Now you know how reactive libraries works, and now the question how to properly apply them at production. First of all, we have to analyze how it works again. Which number of operators do we use and how it impacts our performance? If you're going to, for example, write the code like this, so this is the most common code you can do with Spring Web Flux. How many users of Spring Web Flux do I have in my room? Okay, just a few. I guess the rest of the audience will planning to use Spring Web flags, but probably you will end up with a code like this, where you accept mono, and you produce mono afterwards. And you do a few mapping because this is a cool and pretty fancy way to expose your business logic without math, right? But now let's think a little bit about object overhead that this code brings to our environment. First of all, as we remember, at assembly time, we create publisher. If we provide another map, we wrap previous publisher to another one publisher, another publisher to another publisher, another publisher to another publisher. Then at subscription time, we produce subscription. Then in the chain of subscriber, we create subscribers, and this another n objects. And then we have another n elements during runtime. Comparing to Java stream, proper Java 8 stream, we have a little bit less object, almost the same number, but a little bit less. Comparing to imperative streams or imperative programming, we have 0 overhead from objects, just elements. Do you see that? OK. So from methods called, because objects is expensive, but method calls dynamic invocation, invoke dynamically, which is an instruction for our CPU, is also invocation. And we have now this Russian doll pattern, which is call me this, call me this, call me this. Call me this on next, or on subscriber on complete, or request. And if you're going to calculate the number of calls, we will see that we have n invocation of a next. N, which means that we have to invoke on next on this map, but then on another map, then on another map, and then on another map. So how many operators do we have? That many overhead of invocation we will get. We have n invocation of real function, and then we have m invocation of request, because we can request by 1, so it will be n invocation of request, or we can request by 10, by 100, so the higher number of request size will be, the less performance overhead we get. Yeah, does that make sense? Cool. Java streams, less overhead on invocation. Imperative streams or imperative programming, 0, just business logic. But that's what we have seen at the very beginning of our order processing app. Now let's put the performance comparison and let's try to run a benchmark on the code we have seen before, on this plain controller. So if you're going to handle only one mono, apply just 4 innocent maps, we will get 15% overhead comparing to the same imperative transformation, which means don't write too many maps. Project Reactor or Xjava is not that smart so far. Unfortunately, I'm working on improving the performance. There is a PR for doing some micro optimization during subscription time, but so far, with Reactor 3.1, 3.2, you will get this number of overhead just by writing 4 map for mono. All right, if you got a stream of 10 elements, more elements, less overhead. 1 million of elements, 3% overhead, which means that it's OK if you create long-running stream, then the overhead is pretty small. However, if you're going to kind of put all the data on the chart, we will see that the short-running streams are pretty expensive because the overhead and long-running stream are pretty acceptable. However, there is some trend to which we are going to reach, but never reach. So it won't be a 0 because of the method call overhead. So we have to remember that along with object overhead, there is this invoke dynamic overhead. So to remember, when we start writing production, try to reduce the number of operators you create, because some of them are really expensive. Flatmap creates 2 queues, and then n queues per substream, for example. So it will be really huge overhead, around 40% just by using flatmap, comparing to the same transformation using imperative programming. Yeah, your imperative programming could be a little ugly, but sometimes it's much more it has higher performance. So think twice about applying lots of operations. And yeah, an imperative is much faster. So if you got any questions, if you want to watch at how to create a publish on from array, publisher, keep your seats. Otherwise, you can just scan those links. If you got any question, please ask me. If you are good enough for this evening, yeah, I'm wishing you a good night, consuming all of this information before tomorrow, and maybe asking me questions tomorrow. So thank you Thank you for your attention, and thank you for your willingness to learn something new.